So if you're someone who has started to code using an LLM, watch this video to the end. I want to agree in one way, disagree in one way, and then I have a comment that I think is really important for the audience that isn't directly related to the question. So stay to the end if you're someone learning to code using an LLM. The first thing to note is that Anon is right in a sense. Students who use AI to complete a project have lower retention. This is not limited to coding, by the way. This is like a general artifact of using AI in any category of education. This makes perfect sense under main theories of education, including cognitive load theory and social emotional theory of learning. So cognitive load theory says, like, if you didn't have to try very hard, you're not going to get much neural reinforcement, and you're not going to remember what you did. Social emotional, we can ignore the social part, but the emotional part would say, if your learning experience was low in frustration, you're less likely to reinforce it neurally and less likely to remember it. If it was sort of uneventful, it was a quick chat with GPT and you just copied it over, maybe you read through it, but you're not going to retain what you read as much as if you had to like dig through a bunch of books and like write it out by hand. Even writing things out by hand is neurally reinforcing. And that's about where the agreement ends. There's strong evidence running the other way as well, that GitHub Copilot, language models, multimodal model tools, other AI assistants disproportionately benefit juniors in a variety of other ways. In the case of GitHub Copilot, improving productivity, time to complete coding tasks was disproportionately benefited to juniors relative to others, even though it reduces this ability of the junior to remit information unassisted, sort of like by memory. So there's weaker neural reinforcement, yes. There's actually a mixed bag of pros and cons, and that's the nuance that's missing from this discussion. There is a bit of a crutch effect, but the net effect is a strong positive that takes care of that crutch effect. This puzzle is easily solved when we realize that you can have weak neural reinforcement in a single task, but if you're doing a stream of tasks, the stream is no different. Whether it's one long task, it took you longer doing the traditional way, or it's 5 new tasks that you knocked out quicker with AI. Now you just have 5 of them, but you're still working your 5-day work week. It's just a different number of tasks that week. And so you're still getting cognitive load all week. And if you consider the effect of the work week, whether you use AI or not, you're getting higher neural reinforcement. And so, yes, if you measure a junior after they complete one task, or after they complete one set of tasks, or after they complete one test or one project, they'll exhibit lower neural reinforcement. But if you measure them over time, they're actually growing quicker than if they hadn't used AI. And yes, you're still having social emotional learning with frustration onboarding as a junior in 2024, even if you use AI. There's plenty of experience in that regard as well. Besides these learning theoretic reasons that we can reconcile the apparent differences in the literature, we can build these mental models like the stream model that show that really there's no puzzle here. There's just like studies that haven't been done, but we already know what they would probably say. The other thing that you can look at is you can look at the process itself. So when the novice copies what ChatGPT says over and they're pasting it, very often what happens if the novice doesn't understand is that they get an error. And now they have to read the error and they have to resolve the error. So there is this classic feedback loop like we would have as troubleshooting developers anyway. We just have a new troubleshooting tool. So sometimes they'll get lucky and it'll work right away. And you're right. Sometimes it will work and they don't know why. And this is like something that we should encourage juniors to ask, like, why did that work? That's going to be something we're going to want to emphasize. But frankly, a lot of times it doesn't work and they have to go back and figure out why it didn't work. And then they have to understand the vocabulary. And so they're picking up words from the error message or from using GPT, or after some time, they'll throw their hands up and exit GPT and go to Google and do it the old school way we've been doing it. So there is a full feedback loop here, which you don't get a picture of if you say that they're simply copying it over. The truth is that sometimes they are just copying it over, but this is not the full cover of cases. Like GPT is not that good that they can just always copy it over. There's a bunch of errors involved and they do need to go through the fixing cycle. By the way, like I do one-on-one mentorships and teach people to code. So this is not like speculative things that I'm saying. Like I have a student that I met with on Monday and this literally happened. He's like, GPT said it would work. I don't know why it wouldn't work. And I had to break it down. Like, let's step through and use like old school debugging techniques. So if this function is bound on this React fragment and it doesn't seem to be working, let's start by just having a console log in the component just on render, just to make sure that we're even serving the component at all. Kind of like stuff like that, first principle stuff. And now we're transitioning over to my note. If you are learning to code, the part where I said we want to emphasize you need to be asking why, do that to yourself. Like, ask, why does this work? Try to construct anti-cases and prove them. Like, if I changed it this way, I expect it to break. And then if I did this other thing, I would expect it to work in this other way. Construct those cases. Think about things through first principles. Like, if you're building a React application, try to understand the steps that the program goes through to finally render that on the screen. And realize that today you're not going to get to use those AI tools in the interview for the most part. That may change in the near future. So a bit of memorization goes a long way. I think with a lot of programmers, especially early career programmers, there's sort of a push back against memorization. Like with this leak code thing, like learn the patterns, not the problems, right? Well, the truth is you learn the problems after you know you learn the patterns after you know a few problems, and then you can abstract from them. And you can say, well, 3 sum is like 2 sum because X, Y, and Z, and you can build the mental model of the abstraction. So starting with a little memorization is super useful, I would argue even required. And so yes, when it comes to something like building a web project, having some flashcards to help you understand what is React doing, what is JavaScript doing under React, what is HTML doing under that. Getting some of these basically trivia is still going to be helpful in the interview and when you're going to debug and when you're going to chat with ChatGPT. Believe it or not, ChatGPT in a sense works off trivia because vocabulary is a trivia game. So tokens, ChatGPT is a token reader, a token predictor. This is trivia. When I know a design component is called a modal dialogue, that enables me to have a conversation with ChatGPT, but that is just a form of trivia to know that this thing is called that thing. So learn some trivia. And the particular trivia that you're trying to learn here is the vocabulary of web development. Once you have the vocabulary down, as well as the mental model for rendering, those are going to be 2 powerful tools that I think will get you a junior job pretty much anywhere. Hope this helps. Follow for more. You can sign up for a free site, like a free account at laterally.io. And there's a step-by-step checklist of how I recommend you learn, including projects that I recommend you build. It does involve repetition. I don't think you get away with just building 1 project. So I'm gonna recommend 4. And I do recommend that you use a language model to help you through these things. Language models are my #1 search strategy, but I actually have over 7 search strategies because I know that language models are gonna fail at a certain point of time, and I want to give you lots of other options. So check out laterally.io and check out these search strategies.